Hello again. In this lesson, we'll be talking about conditional probability. For a quick review, let's talk about the probability of an event happening, which is the number of things that you would consider a success, and you divide that by the number of total outcomes, or the total number of outcomes for that sample space. So for example, if you wanted to find the probability of rolling an even number on a dice, well, there are three things that you would consider a success for that probability. 2, 4, and 6. And then there are 6 total outcomes, so it would be 3 out of 6, or 1/2. All right, the probability of A or B. To find the probability of A or B, there's two different formulas that you can use. The second one always works. The first one only works when it's mutually exclusive events. So let's use the one that always works, and that's to find the probability of A or B. You take the probability of A plus the probability of B, and you subtract from that the probability of A and B happening. Okay, and that's the probability of A or B, or A union B, whichever one you want to say. All right, and for a tree diagram, in a tree diagram, you are mapping out your possible scenarios. So for example, let's say that we flip a coin 2 times. All right, the first time we flip a coin, it can either be heads or tails. Okay, and that means that you can also put probabilities here. So even though it says heads and tails, the probability of heads is 1/2, or 0.5. Probability of tails is 1/2. If you flip another coin, or the same coin again, you either get heads or tails again. And once again, the probability of heads is 1/2. Probability of tails is 1/2. All right, and if you get tails the first time, you can also still get heads or tails on the second flip. And once again, the probability is 1/2 or 1/2. And this is a probability tree. All right, we'll talk about using this in today's lesson. So our word for now is conditional probability. Conditional probability is the probability of an event happening after something else has already happened. And you write it like this. This is the probability of A given B. So it's the probability that some event will happen given that some other event has already happened. All right, for example, say that there are 30 students in a class. Of those 30 students, 18 are girls. 9 of the girls play a school sport. Okay, we're going to pick a student at random. What's the probability that the student plays a sport given that the student that we picked is a girl? Okay, so let's say that we picked a girl. We don't know if they play a sport or not. What's the probability that they play a sport given that they are a girl? So basically what we're doing here is resizing our sample space. Okay, so instead of saying uh, 30 students out of 30 students, we're going to say 18. Out of the 18 girls, how many of them play a sport? So if we know that the person we picked is a girl, that means we have 18 possible outcomes now, because we know it's a girl. Of those 18 girls, 9 of them play a sport. So our chances that this person that we picked plays a sport, given that it's a girl, is 9 out of 18, or 1/2. You can also say 50%. So basically, when we talk about conditional probability, all we're doing is we're updating the sample space. We're changing it from what it used to be to what it is now that this other event has happened. Okay, and there's a couple of different ways that it's updated. Sometimes you zone in on a specific part of your sample space, and sometimes you just update how many is available. Okay, so like the previous problem with the girls in the sports, we kind of zoomed into a new subset. Sometimes though, you'll just have one less possible outcome. Like if you're choosing names from a hat and you pick one person and you don't put it back, that now updates your sample space to where it has one less name, so your probability is going to be different. So the formula for conditional probability looks like this. You need to know the probability of A and B and the probability of B to figure out the probability of A given that B has happened. All right, now you might notice right here, what would happen if the probability of B is 0? Now, if you're looking at it just algebraically and looking at the formula, right here you would divide by 0, but you can't divide by 0. That gives you an undefined number. So just thinking about this, if B has to happen before you find the probability of A, and the probability of B happening is 0%, then your probability of A given that B has happened is 0%, because B cannot happen. Okay, for the next topic, we're talking about independent events. Independent events are events where the probability of one event does not change if the other event occurs. Okay, so independent events and mutually exclusive events that we mentioned before are two totally different things, by the way. A lot of students get those mixed up. Mutually exclusive means they can't happen at the same time. They can still be independent or dependent, they just can't happen at the same time. Independent events just means that one of them occurring doesn't affect the probability that the other occurs. So, example of independent events, tossing a coin 2 times. Since you can still get the same, you can get heads or tails in the second toss, the probability didn't change at all. So each toss is an independent event. An example of a dependent event is drawing names from a hat and then not replacing that name. Okay, so for example, if we've got 10 names and one of those names is John, and I draw one name out of the hat and it's not John, now there's not 10 names anymore. Now there's 9 names. So the probability that I'll draw John on the next one, instead of being 1 out of 10 like it was for the first time, it's now 1 out of 9 because the probability changed because the event already happened once. Okay, so the second draw depends on the first draw. The probability depends on the first draw. So that's an example of a dependent event or something not being independent. Okay, so for independent events, the conditional probability of independent events is really simple. For independent events, since B happening does not affect A, then that's going to be the probability of A happening. Okay, this is the probability of A given that B has happened. Well, if they're independent, it doesn't matter if B happened or not. So there you go. All right, so what I want you to do is in your notes, think about a couple of events or a couple of word problems that you can use conditional probability to solve. I also want you to think about, well, one of them should be dependent, and you should use the first formula for it. The second one, let it be independent events, and use this formula for it. I hope you have a very good day.